So let's start with today's derivation, that is potential to an electric dipole. Start with the diagram. We need a dipole. So we will have a positive charge and we will have a negative charge. Just put the dipole. There will be a plus q, there will be a minus q. Just to identify the positions, let's call this as point A and this as point B, and at the center we will have the midpoint, that is the origin of the dipole or the center of the dipole, which we can take it as A. Now we know that for the dipole the distance between the two charges will be, it is always taken as 2A. Then we want an arbitrary point which is neither on the axis, it is not on the equatorial plane. So it is a general point which is at a certain distance from our dipole, and it is at a location which is not on the axis of the dipole and it is also not on the equatorial plane of the dipole. So we are going to take that point P somewhere here, and this is my point P, and for that point P I need to draw the distances. This is the distance of point P from the center of the dipole, and I am going to take it as R, and it is a vector. Then similarly there are two more points, that is point A and point B, which are relevant for us for the derivation purpose. So I am going to take that again, but in this case I am going to take it as a dotted line, and this will be taken as R1. Similarly I will take this dotted line from B to P, and this will be taken as R2. And these three are the lines joining the three relevant points of the dipole to the point where we want to calculate the potential. Now you must observe one thing in this one. This line which is joining the center to the point P, it is making an angle theta with the axis of the dipole. Now one more thing we can take in the place of axis of the dipole, it is our dipole moment. So what is the direction of dipole moment? Direction of dipole moment is from negative charge towards the positive charge. So this is going to become my dipole moment. After that, the explanation. What is the explanation about the diagram? Consider an electric dipole with charges minus q and plus q separated by a distance 2a. That will be your first sentence about the main thing with which we are going to calculate our potential. Then after that, what is the next highlight? It is our point P. So let P be a point at a distance r from the center of the dipole. That will be our second highlighting point, and along with that we need to describe about this angle, and that line OP makes an angle theta with the dipole moment. What is that dipole moment? It is small letter p with a vector sign. Whatever you have drawn, it will be explained in one paragraph, or you can say 3 sentences. First sentence only about dipole, second sentence about the point P, and the third sentence the relation between this dipole and the point P, that will contain this angle theta. So that will complete our first paragraph. After that, let's describe some distances. OP is equal to R, and that is a vector. What are the other distances? It is AP, that will be R1, and what is the other distance? BP, that is equal to R2. Just describe the words, describe the distances what are present there. Then what we need to calculate? We need to calculate the potential due to this dipole at this point P. Now what are the contents of a dipole? There are two charges. If there are two charges, means there will be two different potentials that will be coming to this point P. One is because the plus q charge and one is because the minus q charge, and the total potential will be an algebraic sum of the two potentials. So I need to find the potential of first charge, I need to find the potential of the second charge, the two potentials. So what is that? So first I am going to take it as V1. What is my V1? It is the potential of this minus q charge. So V1 will be equal to 1 by 4 pi epsilon naught. I will take it as minus q divided by R, because that is the equation of potential. V2 will be 1 by 4 pi epsilon naught. It will be just Q divided by R. Now what is this R? This R is from, that is A to P, that is distance is R1 and this distance is R2. The only difference between the two equations is the Q here is a minus Q, Q here is a plus Q, and the distance here it is R1 and the distance here is R2. Now just by observing the diagram, you may conclude that the distance R2 is less than R1. That is going to come in play in the later part of the derivation. So with that, we will move for the next step. What is the total potential? Total potential V will be equal to V1 plus V2. Can I write that equation for V1 and V2? Yes. What is V1? 1 by 4 pi epsilon naught, it is minus Q divided by R1 plus of, what is the other one? It is 1 by 4 pi epsilon naught, it is Q divided by R2. Now just by observation you can say there are many terms which are common that I can take outside. So I can take Q is common in the numerator, so I can take Q divided by 4 pi epsilon naught. Those are the things which are common to both. Now what is next? Inside the bracket I can take it as minus 1 by R1 plus 1 by R2, or in a simple way I can take it as 1 by R2 minus 1 by R1. Because this is with a plus sign, I am going to write it first. This is with a minus sign, I am going to write it in the later part. So next part, again it is just two simple fractions, 1 by R1 and 1 by R2. Just deal with the fractions inside the bracket. We have nothing to do outside the bracket. Everything is done only within that bracket. The outer terms will remain as it is till the last step. But don't forget to write them in each and every step which you are writing. Some of the students do that. If they are processing only the bracket, they will be following only the bracket and they will leave the terms which are outside the bracket. So please don't do such mistakes. So Q divided by 4 pi epsilon naught. What to do inside the bracket? Obviously, some of you must have thought we are going to take the LCM. So what is the LCM of R1 and R2? It will be just the product R1, R2. What we are going to take here? It will be the cross multiplication. So this R1 will appear here and this R2 will appear in this place. So it will become R1 minus R2. I hope till this stage everything is clear to you. What we have done? We have drawn a diagram, we have explained the diagram. After that we have written about the distances which are present in the diagram. After that we have written the individual potentials of individual charges which are going to appear at this point P. So it will be V1 is due to minus Q and V2 is due to plus Q. We have written up to this much. After that, the total potential will be algebraic sum of the individual potentials that we are going to add them. And addition, because there is a minus sign, I am going to take that minus term later and I am going to take the positive term before. So just in the next step, we have taken the LCM. Till this thing, it is simple mathematics. Next part is slightly, it involves geometry, and if you are good in high school geometry, you should be familiar with what I am going to do next. I am going to draw a perpendicular from point B onto the line AP. I am going to label it as N. And just for your understanding, I am going to bring out this triangle outside there because it is relevant in the next step. This is my line AP and this is my dipole. This is point A, this is point B, and I am going to draw a perpendicular like this. That is my point P and this is my point N. I hope you are able to understand this. So now this is a right angle triangle because I have drawn a perpendicular to this line AP from this point P. By the symmetry of this diagram, the theta which appears here, same theta will appear here also, because considering the situation, this distance 2A is much smaller compared to the distance R. So whatever the angle these 3 points make, it will be almost nearly same for all the 3 points at the point P. So I can take this angle theta here. Now, why we need this perpendicular and why we are involving in this theta? Just if you observe, if I take this perpendicular to here, this distance and this distance will be same, because from point B to P it is smaller distance, and from point A to P it is a longer distance. And if I put a perpendicular here, then this distance from B to P and from N to P, it will become same, and this is the extra distance, that is from point P. Why? Because this distance A to N, it will become R1 minus R2, because the distance AP is R1, and from the distance R2 it is N to P, because this B to P is R2, same thing appears here between N to P. So and that is why I am interested in this R1 minus R2, that is going to be represented by this AN that has appeared in the numerator of this thing. So that should give you a clarification why we are getting involved in this thing. So this total distance AP is equal to R1. The distance BP is equal to R2, and the same distance will be equal to NP. N to P will be same as B to P. Now, what is the conclusion of this one? It is AN will be equal to AP minus NP, and that is going to give me R1 minus R. Is the right angle to triangle here. I want this. I know this because that is the line AB and the distance is 2A for that one. Again from this one. It is not a new thing. So I am going to be finding the value of this AN. Now just observe that theta, this line AN, it becomes the adjacent side of this theta. If I was interested in BN, that would have become opposite side. But in this case, I am interested in this side, and this side is adjacent to this theta. And this side is having, this angle is 90 degree. So this becomes my hypotenuse. So what I am going to looking after? I am going to go and look for cos theta. Cos theta will be equal to AN by AB. Adjacent by hypotenuse, that is cos theta. I want AN. AN will be equal to AB cos theta. Now what is the value of AB? We know from this diagram it is 2A. So I am going to write that as 2A cos theta. Now what was my AN? It was R1 minus R2. So I can write it as R1 minus R2 will be equal to 2A cos theta. So I can replace that numerator by this term, that is R1 minus R2 can be replaced by 2A cos theta. So I'm going to rewrite that one, Q divided by 4 pi epsilon naught into, it is 2A cos theta divided by R1 R2, and that is going to be concluded. Next, again one more thing, the things which are in denominator, it is the distance from minus Q to P, distance from B to P. From A to P and B to P, there is R1, there is R2, but in between there is just R. So what we can say, this R1 is slightly more than R, and this R2 is slightly less than this R. That means R1 and R2 are nearly equal to R. So R1 nearly equal to R2 nearly equal to R. So from that what I can conclude, there is R1, there is R2, both can be replaced by R. So what is going to become? It is going to become Q divided by 4 pi epsilon naught. Inside the bracket it is 2a cos theta divided by R square, and that is the closing statement. Now till here everything remains same outside the bracket. Now next part, you should be able to imagine there is a Q outside, there is a 2a inside, and from the diagram we have P is equal to Q into 2a, that is the dipole moment. So I can replace this Q into 2a by this P, and that will be replaced there. So this is going to become V equals P, that is a vector, and that will be cos theta divided by 4 pi epsilon naught R square. And just to take care of that direction, I am going to put that as R cap. And there is a dot product in that one. So if there is a dot product in there, the result will be a scalar quantity. So the final equation is going to become V is equal to P cos theta divided by 4 pi epsilon naught R square. That is my final equation. The only thing you need is you are replacing this thing, so you will write this equation somewhere on the right hand side, that is in the rough column, and also you have to write this R1 equal to R2 equal to R. Only that much is so. What we did, we added the two potentials, we took the common things out, only the denominators were not common, so we added them, so it will become 1 by R2 minus 1 by R1. Taking the LCM, it is going to become R1 minus R2 divided by R1 R2. So till here I hope it was clear. For this numerator, we will get into this right angle to triangle will be formed using a perpendicular from point B to point P. There we are going to get a right angle to triangle. Whatever the theta appears here, same theta will appear here, same theta will appear also at point B. But we are interested at point A. So we took out that point A and we made the cos theta of that one. We got adjacent divided by hypotenuse, and adjacent will be equal to AB cos theta, and the value of AB is 2A. So it is going to become 2A cos theta. So that AN was already R1 minus R2. So that R1 minus R2 will be equal to 2A cos theta, which I will be substituting in the numerator. After that, in the denominator, the R1 and R2 terms are nearly equal to each other, and that distance will be equal to this position vector of R, and that is going to be appearing in the denominator. Then in the next step, we know that Q into 2A, that is going to give us the dipole moment. So Q into 2A will be replaced by a P, and that P will be multiplied to this cos theta, and the direction will be in the direction of this position vector R. So I have added that dot, that is the unit vector, and there will be a dot product between these two, and that is going to give us a scalar quantity, that is the potential V. As a concluding remark, this equation is the completion of that derivation. Just as I usually give it, V is proportional to 1 by R square here. In what case it is going to be true? Only for the case of dipole. This R square is not going to appear anywhere else in this chapter except for this derivation. Only for this specific case, that is for the case of electric dipole, we will get that as R square. Now just as a side, you have seen the derivations in the first chapter. We saw the Coulomb's law, there was a R square. We saw the electric field, there was a R square. But when we entered into the dipole, there was R cube in the denominator. That means wherever we are going to come across a dipole, the R, that is the distance power, will be 1 more than a normal situation. Special cases, there is a possibility that this point P can appear here, because we took a general case where theta is like this. The theta can become 0 and this point P will come on the axis. That is one possibility. Another possibility is that the P is going to turn here and is going to appear on the equator. There is another possibility that the P is going to turn all the way till A and again it is going to appear on the axis. So on the line of the axis, if this point P goes here or the point P goes here, that is, this angle theta can either become 0 degrees or it can become 180 degrees. We have those values for this cos theta. That is, first special case is if theta is 0 degree or 180 degree. It means P is on axial line. In this case, what should happen? If this goes here or this goes here, that theta value in that equation will be either a 0 or 180 degree. If that theta value becomes 0, cos 0 gives us plus 1. And if that theta value becomes 180, the theta value becomes minus 1. So, but the term remains same. There is no change with the value of P. There is no change with 4 pi epsilon naught. Those are the constants. And there is also no change in r square. The only thing that changes is theta. And that theta is going to decide the value of, in this case, that is the value of the potential. So, in this case, V will become plus or minus. If it is 0, it will be taking the plus sign. If it is 180, it will take the minus sign. Cos theta has taken the value. What is left in the numerator? It will be P divided by 4 pi epsilon naught r square. So that is one special case. Next, another special case, that is if theta becomes 90 degree. I hope you can recall the value of cos 90. That is the second special case if theta equal to 90 degree. Or you can take it as 270 also, but that is not going to make any change because it is going to give us, implies P is on equatorial line, implies V equals 0. So if this P comes here on the equatorial line, at that point that cos theta was there, cos 90 is going to give us 0, and that 0 will be in the whole plane of that equatorial region.